we're gonna do a few more examples on what is that? Undetermined coefficient. So they're asking us to solve y double prime minus 5y prime plus 4y equals to e to the x. Okay, so number one, I don't think we have the solution to this differential equation. Yes, no, we don't have it here. So let's get the corresponding characteristic equation. This is to get the homogeneous solution. Well, this is a trinomial, factors of m that add up to, I mean, factors of 4 that add up to -5. Is that, are they -4? And 1, -1, actually. And by the zero product property, m equals to 4 and m equals to 1. All right. So writing down our solution to this, we get y sub c, that's the homogeneous, that's c1 e to the 4x plus c2 plus c2 e to the x. All right. And guys, again, does it matter which one do we write first? Does it matter if I write c1 e to the x and c2 e to the 4x? It doesn't matter. In the end, it's just a linear combination. And then well, it doesn't matter. Okay. All right, well, let's have a look at the second part of the problem. Well, what do we have on the right-hand side of the differential equation? Well, e to the x. So this is an exponential function with essentially nothing being multiplied with. Well, that nothing is really a constant. So the form of y sub p will be a e to the x. All right, take the necessary derivatives. Essentially, that's this. It's two derivatives. Okay, I'm gonna go a e to the x and y double prime of p sub p. Another a e to the x. Okay. Well, there's really no change about this one. All right. What do we do with this? Substitute back into the differential equation. All right. Well, so to get this done, so substitute y double prime, which is what? A e to the x minus 5 times a e to the x plus 4 times a e to the x. And that equals to e to the x. All right? Well, what we get on the right-hand side of the equation, 4a plus a, is that 5a minus 5, we get 0 equals to e to the x. So actually the coefficient we are set to determine is gone. So we have a problem here. We have a big problem here. So we can't solve the problem because of this situation. Well, what's the problem behind all this? What's the behind the scenes here? Well, so one thing to notice here is that whatever we have on the non-homogeneous side of this the input function, did you guys notice that it is a repetition of one of the linear combination of one of the elementary of the fundamental set of solution from the homogeneous solution? So whenever we have a repetition, which we didn't have in previous exercises, first exercise we get with this situation, what do we do? So when y sub p contains terms that duplicate terms in the solution to the characteristic equation, the homogeneous solution, then the test function or the guess of the function y sub p must be multiplied by a power of x, where x to the by some x to the n, where n is the smallest positive integer that eliminates that duplication. How does that work? Well, so they're asking us to solve, what is that? They're asking us to solve the equation using now this technique. Okay, let me copy and paste because we're going to use the same solution. So copy, well, actually just copy the solution. That's fine. You don't need to write, you need to solve the whole problem again. So y sub c equals c1 e to the 4x plus c2 e to the x. All right. Well, what about y sub p? Okay, so for y sub p, because again, in this case, a e to the x didn't work because that's actually a duplicate. All we're going to do is multiply this by a power of x. So, okay, multiply by one power of x. Does that function, ax e to the x, look like a duplicate of the solution to the homogeneous equation? No, so we can go ahead and find the necessary derivatives for this one, which, by the way, product rule, y sub p equals to, what is that? Um, so the derivative of ax is a times e to the x plus the derivative of e to the x, which is e to the x times ax. And then the second derivative, this is y prime, then this is y double prime. The derivative of a e to the x is itself a e to the x, and the derivative of ax e to the x, it's actually all this madness here, right? Plus a e to the x plus ax e to the x. You might want to combine like terms here. Actually, the first two terms are like terms here. So y sub p double prime, that'll be 2a e to the x plus ax e to the x. Okay. Yeah, I think I'm gonna need a little bit more room here. Okay, let me move this all the way here, and this maybe below. Well, maybe here. That's fine. All right, so now let's substitute this into the differential equation. Well, actually, I should have used a different color for this, just to distinguish from everything else. Okay, so now we're going to substitute all of this into the differential equation, and so 2a e to the x plus ax e to the x. So that's the second derivative, right? And then what is that? What's next? Minus 5, okay? Minus 5 times the first derivative, which is a e to the x plus ax e to the x. And what else? Plus 4 times y, that is plus 4a x e to the x, and let that be equal to e to the x, okay? So let's see what's going to happen here. All right, so let's combine or distribute the negative 5, combine like terms whenever applicable. So this will be 2a to the x plus ax e to the x minus 5a e to the x minus 5ax e to the x plus 4ax e to the x, and let that be equal to e to the x. Not enough space to fit everything. All right. Well, guys, this is what we will be obtaining, so don't be scared about it. Just go with it. I mean, unfortunately, there is no shortcuts to avoid all this work. So just be careful with managing your terms. So I'm going to use different colors to highlight like terms, like these two right here. They are like terms. They are constant times exponential. And what else do we have? Variable, oops, variable times exponential. Okay. All right. So combining like terms, well, actually, check this out. Do you guys agree how ax plus 4ax that adds up to 5ax, right? Minus 5ax, actually all of this go away, and we're just left with 2a minus 5a. So that's 2 minus 5. Is that equal to negative 3a e to the x? Okay. And well, here is where we equate the coefficients. What is the coefficient of the exponential on the right-hand side? You guys agree it's an invisible one? So negative 3a equals to 1, and a equals to negative 1/3, right? So only one coefficient to get. Go back to y sub p, okay? So this means y sub p equals to negative 1/3, all right? X e to the x, okay? All right, so now we can write this general solution, y equals to y sub c plus y sub p. That is The general solution, the homogeneous solution, C1 e to the 4x plus C2 e to the x minus 1/3 x e to the x. All right. And final answer. So this one. So baby examples here. Let's see what do we have for the next example. Okay, let's see about it. Okay, so solve each differential equation below. So now we're going to look at a couple of exercises plus something else, yes, where we will have to use this multiplication by x to some power because whatever we have on the right-hand side, the non-homogeneous part of the equation is a duplicate of what we got from the solution to the homogeneous differential equation. Well, so let's solve this equation. So y double prime minus 2y prime plus y that has characteristic equation m squared minus 2m plus 1 equals to 0. And well, this factors to m minus 1 times m minus 1, which actually, guess what? This is m equals to 1 repeated, right? So the solution to a homogeneous equation with repeated roots, well, this is y equals to c1 e to the x plus c2 also e to the x, but we multiply by 1 power of x here, right? So that's just the solution to the homogeneous part of the problem, all right? Now let's have a look at what you call it, at the form of y sub p. So what do we have for y sub p? Guys, do you guys agree that we have again the same e to the x function, the same exponential function? Okay, so let's have a look. So y sub p equals a e to the x at first glance, but do you guys agree this a e to the x is a duplicate of the first term in our homogeneous solution? Okay, so what do we do? Multiply by a power of x. Great. But wait a minute. Isn't that still a duplicate of one of the terms in the homogeneous solution? So just multiply by x, it's not going to be enough. Then we multiply by x squared. Now compare. Is that a duplicate of one of our solutions from before? Not anymore. Let's go ahead. Okay. So y primes of p equals to, okay, 2ax e to the x plus ax squared e to the x. All right. So using the product rule, this is what we get. All right. Now, find the second derivative here. Okay, the second derivative is going to be a crazy one. So y double primes of p. So one product rule for the first term, right? So the derivative of 2ax, that's 2a times e to the x, plus the derivative of e to the x, which is itself e to the x times 2ax. So that's just the derivative using the product rule for the first term only. All right. Now let's differentiate the second term, which is ax squared e to the x. But actually, we already differentiated that. Isn't that this whole, it's the same as the first derivative of the guess of the function? So just copy paste, all right? 2ax e to the x plus ax squared e to the x. So simplifying, combining like terms, what do we get here? Okay, so looks like these two are alike terms. Let's combine them. So this is 2a e to the x. We're going to combine 2ax e to the x plus 2ax e to the x. That equals 4ax e to the x plus ax squared e to the x. All right. Now let's go ahead and substitute into the differential equation. Okay, so go back to blue here. So substituting the second derivative, which is all this madness we just computed here, that's 2ax e to the x plus 4ax e to the x plus ax squared e to the x minus 2 times the first derivative. This minus 2 will affect the entire first derivative, which is 2ax e to the x plus ax squared e to the x, all right? Plus y, which is ax squared, rather, e to the x, and that equals to e to the x. Okay, barely space, all right? Barely have enough space to fit all of it. Okay, guys, the rest of the problem is just algebra. Again, managing all of these terms. Careful with, okay, so let's distribute. Okay, the first three terms just remain there. So 2ax e to the x plus 4ax e to the x plus ax squared e to the x. Okay, distribute carefully here. Okay, negative 2 times 2, negative 2 times a. Okay, so minus 4 ax e to the x minus 2 ax squared e to the x. All right. And the last term, just bring it down. So plus ax squared e to the x equals to e to the x. Okay. Okay, let's use some highlighters here to combine the terms together. Okay, so constant times, wait, no, what am I doing? Okay, okay, let me do the quadratics. Wait a minute, there's an x right here that should not be there, right? Yes. Yeah, one mistake like that, boom, the whole problem is wrong. Okay, let me move this together because I was looking at my notes and yes, okay. So constant times exponential. We don't have another one like that, right? Okay, let's move on to the next one. Use green. Okay, so x to the first power, x to the first power, and that's about it. Actually, check this out. Do you guys see how they go away? They cancel out. All right. Use a different color for quadratics. Quadratic, quadratic, and quadratic. But do you guys also see how the quadratic terms also go away? Because ax squared plus ax squared, that's 2ax squared minus 2ax squared. Boom, they also go away. Okay? Cancel, cancel, cancel. And we're left only with 2a e to the x equals e to the x with an invisible 1 coefficient, which means 2a equals to 1 and a equals to 1 half. All right. So now we may go ahead and write y sub p. So y sub p equals to 1 half, or maybe here 1 half x squared e to the x. All right. So we may go ahead and write the general solution. Y equals to y sub c plus y sub p, which is c1 e to the x plus c2 x e to the x plus 1 half x squared e to the x. All right. So a couple more exercise. I believe there's one more on the, yes. Yes, there's another one. There's a big one. All right. Okay. The next one. Okay, let's flip the page. Let's move on to the next page and solve another second order differential equation. Okay. So what do we have? Y double prime minus 6y prime plus 9y equals to 6x squared plus 2 minus 12 e to the 3x. Okay, again, let's get the auxiliary or characteristic equation for the homogeneous equation. Okay, so that's m squared minus 6m plus 9. Let that be equal to 0. Factors of what is that, of positive 9 that add up to negative 6, are there any? That negative 3, another repeated case, right? Another repeated case. So this means m equals to 3 but repeated. All right. Here we go. Okay, so y sub c will be c1 e to the 3x plus c2 e to the 3x, but in this case, again, make sure to multiply by a power of x in this case. So unless we have even more repetitions of the same, we just add more powers of the same. We did a couple of exercises back in the previous section about that. All right. All right, let's see. Have a look. Let's have a look at what is that? Y sub p. Y sub p. What do we have on the right-hand side of the differential equation? Okay, let's analyze what we have. Actually, I'm going to analyze this in two parts. Number one, the uh, the polynomial part, which in this case it's a second degree polynomial. It's a quadratic, so we will need a generic quadratic polynomial here. So that'll be ax squared plus bx plus c. All right, so that's one. Number two, number two, uh, me use a different color here. Okay, the exponential. The exponential, well, that's just a constant times the exponential. Lucky for us, it's not a power of x. Oh, let's see. We need to continue with the alphabet. So plus d e to the 3x. Okay? We have a problem again, right? You see what's the problem? That exponential is a repetition. Okay? So need to multiply only the guys, only the exponential term by a power of x that eliminates duplication. In this case, x squared. Because what do we have on the homogeneous solution? Well, x to the zero power essentially, x to the first power. Well, notice I didn't do any side note like I'm doing here in the previous exercise because the previous exercise only had one term in on the right hand side of the differential equation. So this one we have a combination of a polynomial and an exponential. And again, we only multiply. So here's the tricky part. We only multiply by a power of x only to those terms that look like a duplication of the homogeneous solution. For instance, look at the homogeneous solution. Does the homogeneous solution contain polynomials? So the polynomial part has no repetition. So now let's change our minds here and we write y sub p equals to ax squared plus bx plus c plus dx squared e to the 3x, right? So here we go. Let's find the two derivatives, okay? So y prime sub p equals 2ax plus b, the derivative of c is 0, plus, oh, a product rule here, right? So the derivative of dx squared, that's 2dx e to the 3x plus the derivative of e to the 3x, which is itself e to the 3x, and I'm going to multiply by 3 in the front of the x squared, okay? So that is the first derivative, all right? So what about the second derivative? So for the second derivative, ooh, okay, so that is 2a, y double prime sub p, that's 2a. The derivative of b, do you guys agree that's 0? And here we will need two product rules, okay? Careful, let's do one product rule at a time. The product rule for this first exponential term times some x right here. So the derivative of 2dx, that's plus 2d e to the 3x, okay? Plus the derivative of e to the 2x, which is itself e to the 3x, not 2x, times, okay, I'm gonna save this 3 for later here, all right? Uh, times 2d x. But multiplying these 3 times these 2, isn't that going to give us really a 6? Okay. And, oh boy, how do we write the next part? Okay, let me make some room first, because I may need it. All right. So now we need to differentiate this 3dx, what is that? 3dx squared. This is a square, not a cube. Squared e to the 3x. But guys, we actually differentiated this dx squared e to the 3x before in the a couple of lines ago. So I'm going to do simply plus 3 times whatever we get from differentiating this product, all right? That is 3 times these two terms actually. That is 2d x e to the 3x plus 3dx squared e to the, make some room. Okay. Oh no. Make some room here. Yes. E to the 3x. All right. But still, I still need to distribute that 3, right? Okay. So y sub p double prime. So that's 2a plus 2d e to the 3x plus 6 dx e to the 3x plus, okay, guys, careful here. We're going to distribute, distribute. So that's going to give us, okay, well, let me actually distribute and then combine like terms. That's fine. Okay, so that's a 6 dx e to the 3x plus 3, wait, plus 9 dx squared e to the 3x. Okay, let's combine like terms. Guys, you don't want to substitute all of this into the dE. So combine any like terms, which are actually 6dx e to the 3x with 6dx e to the 3x. Okay, y sub p double prime, that's 2a plus 2d e to the 3x plus 6d, I mean 12, dx e to the 3x plus 9d x squared e to the 3x. All right. That's just the derivatives, guys. We still, okay. The fun part is the next part, all right? The substitution into the differential equation and finding the coefficients. All right. So here we go. Second derivative, which is all this madness here with 4 terms. All right. So okay, let me make this. No, I'm not gonna have enough space here. So 2a plus 2d e to the 3x plus 12 dx e to the 3x plus 9dx squared e to the 3x. That's just a second derivative. What else do we have? Minus 6 times the first derivative, which is y sub p prime, which is how many terms? All these 1, 2, 3, 4 terms. Okay, 2ax plus b plus 2dx e to the 3x plus 3dx squared e to the 3x. All right. And then plus, I'm going to go on the next line because I'm not going to have enough space in here. So plus 9 times the original function y sub p, which is ax squared plus bx plus c plus dx squared e to the 3x. And let that be equal to the function on the right-hand side of the dE. That is 6x squared plus 2 minus 12 e to the 3x. All right, what's next? Okay, let's distribute and combine any like terms whenever possible. So the first four terms remain the same. 2a plus 2d e to the 3x plus, this is not 120, this is 12d x e to the 3x plus 9 dx squared e to the 3x. Okay, minus 6 times 2 is that minus 12. Okay, minus 12 ax minus 6b. What else? Minus 12 dx e to the 3x, and then minus 18 x squared e to the 3x. All right. What else do we have? The distribution of 9 times the y's of p. That is plus 9. Yes. Which one? Oh, right here, right? Thank you, thank you. Oh, yes, very important. Thank you. Plus 9 times ax squared plus 9 times bx. And then I'm going to continue here plus 9c plus 9 dx squared e to the x, e to the 3x rather. And let that be equal to 6x squared plus 2 minus 12 e to the 3x. Okay? For many kinds of terms, I'm going to use highlighters of different colors to bookkeep all of them. Okay, let's get started with constants. Okay, I'm going to use yellow for constants. So 2a, we have another constant term, the 6b minus 6b. All right, and the 9c over here. All right. What about, okay, constants times x to the first power? I'm going to use pink, okay? So that is negative 12ax, 9bx. Is there another one? I believe that's about it, right? Okay, what about constants times quadratics? I'm going to use green highlighter, and I believe that's the only one, right? There's no other one. Okay, let's get into constants times exponentials. I'm going to use blue. Okay, constant times exponential. Looks like that's the only one, right? Okay, what about constant times x to the first power times the exponential? Let me use red for this one. And this one and that one. Actually, those are going to get canceled, right? Well, we'll get into the cancellations next. Okay, how about quadratics times constant times times exponentials? I'm going to use brown here. This one, that one, and that one. All right. Okay, cancellations. So actually, all the quadratics times exponentials go away because 9 plus 9 equals 18 minus 18. Goodbye. All right. 12 dx minus 12 dx also goodbye. All right. Anything else to cancel out here? I believe that's about it, right? Okay, so let's get this in order somehow. Okay, remember the form of y sub p? Quadratic, linear, constant, quadratic times exponential, right? I'm going to write the terms that survive the cancellation in that exact same order. Why? Because we're going to use that format to equate the coefficient. Okay, here we go. Okay, so the quadratic 9ax 9ax squared. What about the constant times x? Okay, so the pink ones. There's two pink ones plus negative 12. Okay, parentheses negative 12a plus 9b times x. All right, plus what's next? Oh, constants. Okay, so because this is quadratic, this is linear. Now constants, the ones in yellow here. That is I'm going to open parentheses, okay? I'm going to open parentheses to group them. 2a minus 6b plus 9c. And what's next? Okay, the next that survive the cancellations where the exponential 2d plus 2d, 2d e to the 3x. And let that be equal to 6x squared. Okay, be careful here because what do we have here? Quadratic, linear or x to the first power, and constant. The polynomial, the quadratic polynomial here is missing the linear term. So, well, it's there in spirit. Let's summon the spirit by adding a coefficient 0 because it's going to be useful to when we equate the coefficients. And finally, not yet. We're not even, we're barely halfway through the problem. Okay, maybe a little more. So let's equate coefficients. Okay, so the coefficient of x squared, which is 9a, that should be equal to the coefficient of x squared on the right-hand side. You guys agree? 9a equals to 6. Okay, so a equals to 2/3. Score. Now, the coefficient of x to the first power has to be equal to the coefficient of x to the first power on both sides. So that means negative 12a plus 9b, is that equal to 0 in this case? Well, that's one equation, two unknowns. However, we already know the value for a. Negative 12 times 2/3 plus 9b equal to 0. So 12 over 3, is that equal to 4? 4 times 2, is that equal to 8? But negative 8, so that's 9b plus 8 equals to 0. 9b equals to negative 8, and b equals to 8 over 9. All right? Okay. So the constant term on the left-hand side must be equal to the constant term on the right-hand side. Or if you prefer, check this out. The coefficient of x to the 0 power equals to the coefficient of x to the 0 power. If that works for you, well, that's another point of view, all right? You don't have to do all this. If constant equals to constant works for you, perfect, all right? So 2a minus 6b plus 9c equals to, what's the constant value? 2? Let me actually erase it. Looks kind of weird, right? Okay, one question, three unknowns, but we already know a and b. So 2 times 2/3 minus 6 times 8 over 9 plus 9c equals to 2. Okay, so 4/3 minus 48/9. Wait, yeah, minus 48/9. Oh, actually, we can reduce. So that's 4/3. This number reduces to 16 over 3, actually. Okay. And plus 9, C equals to 2. Combining 4/3 minus 16/3, is that negative 12/3? Yes. Okay, okay, so back to B. Okay, so this was supposed to be negative here. This becomes positive, and now positive here. Okay, thank you. So yes, okay, okay. So combining these two numbers, 4 minus 16, is that negative 12? Negative 12/3. Isn't that negative 4? So 9c minus 4 equals to 2. 9c equals to 6, and c equals to 2/3. Okay, what about equating the coefficients of the exponential? 2d equals to negative 12. 2d equals to negative 12. So d equals negative 6. All right? Okay, so let's get going with this. So let's write y sub p finally equals, what was that? A, which is 2/3 x squared plus b, which is 8 over 9, x plus 2/3 minus 6 e to the 3x. All right. 6 actually 6x squared, right? E to the 3x. Okay. So now let's write the general solution, which is y equals to, okay. All right. So y equals to y sub c plus y sub p. Okay. Which is c1 e to the 3x plus c2 x e to the 3x plus, oh my god, that polynomial went away. Well, let me just write it down. All right. 2/3 x squared plus 8/9 x plus 2/3 minus 6x squared e to the 3x. We're not done yet. We just need to box our final answer here. All right. Okay, well, just comment. So when you go back and watch the video, well, we had a glitch in the system here, but I don't think it saved the solution to C right here. So just, well, let me just write the solution for C equals to 2/3, and then 2D equals to -12 to equate the coefficients of exponentials, where D equals to -6. Or simply rewind the tape a few seconds, and that's it. All right. All right. So, yes, we're not. Let's see. Let's see what's next. Okay. Example number 5, more practice on y sub p. However, rest assured, we're not going to solve the equations. All we're going to do is analyze the solutions to the homogeneous equations we have here, and then consider what we have on the left-hand side of the equation, and the right-hand side, rather, to write that solution to, or right, I mean, that potential y sub p solution. Okay, so again, just determine the form of y sub p. Do not find the undetermined coefficient. You'll see why not. Okay, so in this case, left-hand side, it's only y double prime, right? So y double prime, that means m squared simply equals to 0. But I mean, what's the solution to m squared equals to 0? M equals to simply 0, which is repeated, isn't it? So it's a repeated solution. Uh, so y sub c will be c1 e to the 0x plus c2 x e to the 0x. But what's e to the 0x? Isn't that just 1? So y sub c will be c1 plus c2 x. Okay? All right, let's have a look at y sub p. Okay? Y sub p equals to, well, what do we have on the right-hand side of the differential equation? Do you guys see the cubic polynomial? All right. So we need a generic and complete cubic polynomial. Even though we don't have the quadratic term here, well, we have it. It has a coefficient 0. And we don't have the constant term, well, we have it. It's a 0. They're invisible. So we still need ax cubed plus bx squared plus cx plus d. Okay. And well, let's see if that solution works. Does that solution work for this equation? How do we know? We need to determine whether we have some duplicates with the homogeneous solution. All right? Okay. What about this D right here? Do you guys agree that this D is a duplicate of C1? Because they are of the same degree. So no, we may need to multiply the entire polynomial by x. All right? However, if we multiply this by x, what are we going to have? Dx, okay? But isn't that dx a duplicate of c2x? So we need to multiply by x squared, okay? Now, when we distribute, the lowest degree term is going to be a dx squared right here, which is no longer a duplicate in the homogeneous solution, right? So this should work. Okay, so y sub p equals to ax to the fifth power plus b x to the fourth power plus cx cubed plus dx squared. With this, it's easier to see that none of these terms right here are duplicates of the homogeneous equation here. All right? Okay, letter B. So for letter B, we have a fourth order differential equation. Well, I'm glad we don't have to solve the differential equation because we would have to find four derivatives with duplicates with, I don't know how many product rules is there going to be that, right? Maybe for the exam, one like that. I'll think about it. Yeah, I'll think about it. Okay, well, let's solve this homogeneous equation. So that means m to the fourth plus m cubed, let that be equal to 0. All right? Well, we can solve this polynomial by factoring m cubed times m plus 1, let it equal to 0. And over here, be careful. This is m equals to 0 repeated 3 times. Or you can also say that m equals 0, it's a 0 of order 3. That comes from college algebra or pre-calculus when you discuss all that theory about polynomials, the rational root theorem and all that. And this is m equals to negative 1. All right? So here we go. So that means the solution to the differential equation would be y equals to, again, c1 e to the 0x plus c2 x e to the 0x, and then because it's repeated 3 times, c3 x squared e to the 0x, um, plus c4 e to the negative x. Okay? Well, let's simplify the exponential. So y sub c, actually, this will be c1 plus c2x plus c3x squared plus c4 e to the negative x. All right. Let's see. So what about the form of y sub p? Okay, be careful here because the form for y sub p will be, do you guys agree this is just a constant? This is just a number. It doesn't have any x's. Yes, we have some x squared out there. However, the x squared, it's multiplying with the exponential here. All right, be careful. It's not 1 minus x squared to come up with a generic quadratic. Yes, we still need a generic quadratic, but that generic quadratic will multiply with the exponential, will not be a standalone term like, well, like the 1. Okay, so y sub p. Y sub p equals to, so some constant a to take into account for the 1, plus quadratic times exponential, that is a x, oh, wait, b x squared plus cx plus d e to the negative x. All right? So let's see, what about it? Okay, so this is a constant, right? Do you guys agree that this constant is a repeat, it's a duplicate of c1? So we need a power x, all right? However, ax is a duplicate of c2x, right? So we need a quadratic. However, ax squared is also a duplicate of c3x squared, right? So no, it's not going to work. Ax cubed, all right? So yeah, that's going to do it. What about c4? Okay, c4 e to the x. Okay, think about this. What if you distribute this exponential here, all right? Don't distribute it, but what if we distribute it? We would have some d e to the negative x, right? Which happens to be a duplicate of c4 e to the negative x, right? So what do we need in this case? How about multiplying by 1 power of x? Should that do the work? Well, x e to the negative x times a constant. Do we have something like a c5 x e to the negative x? We don't have that, right? So because we don't have that, well, actually multiplying this by x works. Okay, guys, so the point of this exercise is that notice how we have on the one hand a constant, and here we have a quadratic times exponential. In this case, two different kind of functions. So for one of them, we require one a certain power of x. For the other one, we require another power of x. We don't have to multiply all of them by the same power of x. So I could have made this problem even crazier, maybe adding another I don't know. Well, maybe not. No, maybe not. Maybe this is good enough. All right. Yeah. So the bottom line here. Different powers for different functions. That works. All right. Well, do we really want to rewrite? Well, maybe yes. Why not? So, because what if you were to solve this to actually solve the problem? Well, y sub p equals to ax cubed plus distribute the x. That's bx cubed plus cx squared plus dx e to the negative x, all right? Because you don't want to do a triple product rule. You just want to do a product rule with two factors, all right? And yes, that'll be the form of y sub b, all right? No, I don't want to find four derivatives of that function, all right? Good luck with that, all right? If you have time in your leisure time, you want to try it, all right? But no, I don't want to do it, at least not here, all right? Okay, one more and wrap it up. So y double prime plus 4y equals to sine 2x plus cosine 2x. All right. So number one, the characteristic equation would be m squared plus 4 equals to 0, where what do we have? M squared equals to negative 4, and m equals plus or minus the square root of negative 4, which is plus or minus 2i. Essentially, check this out. This is 0 plus or minus 2i, all right? And the reason why I'm writing this in the format alpha plus beta is so we can see exactly what's alpha equals to 0 and beta equals to 2. So the solution, y sub c equals to e to the 0x c1 cosine 2x plus c2 sine 2x, where y sub c will be, well, e to the 0x is just 1 times c1 cosine 2x plus c2 sine 2x, all right? It's one of the undamped solutions, right? Because the exponential equals to 0. Positive exponential overdamped, negative exponential underdamped, all right? Okay, let's see. What's next? Y sub p. So y sub p, what do we have for y sub p? Number one, okay. So believe it or not, we're gonna have two totally different solutions. Number one, so yes, we have the pair sine and cosine. However, be careful because this sine and cosine have different angles. So we would need a pair of sine cosine for the sine 2x and then another pair of sine cosine for the cosine 3x, all right? So let me actually use the same colors. So that is ax, I mean, no, not ax. So that's a sine 2x plus b cosine 2x and another color plus plus c sine 3x plus d cosine 3x. All right. Let me actually make some room here. Okay. Now, here is the thing. Observe the proposed form of y sub b. Do you guys agree that sine 2x, right? Sine 2x, cosine 2x, it's a duplicate of the homogeneous solution? Do we have the same problem with the sine 3x, cosine 3x? So the only one we need to fix here is by multiplying by 1 power of x, that is the first group. All right? So actually, after distributing, we no longer have that duplication. Okay? So y sub p equals ax sine 2x plus bx cosine 2x plus c sine 3x plus d cosine 3x. All right? Final answer. Is there anything else? No, I think that's about it. That actually completes the section.